right, class, hello. This is going to be our high school algebra, and we're going to be talking about the zeros of polynomials. So we've got our standard pasted right up here. We're going to be doing math content high school algebra APR B3, and we're going to be identifying zeros of polynomials when suitable factorizations are available. So that's what we're going to be talking about today and learning how to do. So first of all, let's talk about what are the zeros of polynomials. So the zeros of a polynomial function are going to be our input values, or our x values, that make the output y equal to 0. So on a graph, these are going to be the locations where the graph intercepts the x-axis, or where the graph is equal to 0, in other words. So on this little sketch of a graph that I have down here, where are our zeros going to be located? They're going to be located here, here, and here, where I just highlighted it in blue. Right, so these three locations are going to be the zeros of this little example sketch function. Um, so let's go over a quick example of how to find the zeros of a function. So we're going to find the zeros of the following and verify the results graphically. So right here we've got a real simple equation. Y is equal to x squared minus 1. So this is an even square polynomial, and we all know how to factor this. But first of all, how are we going to find our zero, right? As we can see again up here, zeros are going to be our x values that make the output y equal to 0. So we need to plug in 0 for our y, and that's going to be really easy. We'll just plug in 0. So 0 is equal to x squared minus 1. All right? So how do we solve from here? We're going to have to factor this. And again, we already know how to do this, right? X squared minus 1, that's an even square. So we're going to have x plus 1, x minus 1 there in our factoring. So now here, how do we find when the function is equal to 0, right? If either one of these terms here, x plus 1 or x minus 1, is equal to 0, then the whole function is going to be equal to 0 because they're multiplied by each other, and as we know, anything multiplied by 0 is equal to 0. So we can take these two terms separately and set them equal to 0. X plus 1 is equal to 0, and x minus 1 is equal to 0. Subtract 1 on this side, add 1 on this side, right? And then we have x is equal to negative 1, and x is equal to 1. And those are going to be the zeros of our function. It is that easy. All right, so we're going to have to verify this graphically. So our function is y is equal to x squared minus 1. As we can see, that's going to be a standard quadratic equation. So it's going to be in the shape of a parabola, x squared, with a y-intercept at negative 1. So it's going to look a little something like that here. That's just a quick sketch of that. So where are our zeros going to be? Sure enough, at negative 1 and positive 1. There we have our zeros of that function. We just solved it graphically and algebraically. So let's move on to another example. So we're going to factor the following and find the zeros, and we're going to verify our results graphically. Here we just have a slightly more complex equation to work with. We have y is equal to x squared plus 5x plus 6. So again, we're going to substitute 0 in for the y. We're going to have 0 is equal to x squared plus 5x plus 6. And as real quick review, how are we going to factor this equation out? Right, we're going to need two numbers that add up to 5 and also multiply to equal 6. And I think we can all agree that 2 and 3 are going to be the right numbers for that, right? 2 plus 3 is equal to 5. 2 times 3 is equal to 6. So if we factor this out, we're going to have 0 is equal to x plus 2 times x plus 3. And that's going to be our factored form of that equation. Like before, we can set those separately equal to 0. X plus 3 is equal to 0, and x plus 2 is equal to 0. subtract 2 on that side, subtract 3 on that side, right? Then we're going to have our zeros are going to be equal to x is equal to -2 and -3. And there are our zeros just like that. So if our zeros are at -2 and -3, we're going to have to verify that graphically. Again, this is just a quadratic equation with a positive leading coefficient, right? So it's going to be a parabola facing upwards. The zeros are going to be at -3 and -2, so our vertex is going to be somewhere around right here-ish. And that graph is going to look a little something like that with our zeros at negative. I put those zeros at -1 and -2. My apologies. Disregard that, class. We're going to have our zeros at -2 and -3, not -1 and -2. I drew them in the wrong spot. There we go. Our function's going to look a little something like that. Alrighty. Now we're going to have a you-try example. So you're not going to have to graph this function, but you're going to factor the following, and you're going to find the zeros of the function, right? So I want everyone to go ahead, pause the video really quick, and take a couple of minutes to factor this equation here and solve for the zeros. And you're going to have an option to fill out your answer on the right. And yeah, everyone go ahead, pause real quick, and work out this equation by yourself. All right, so hopefully you were able to do that without any real problems. It should be straightforward enough, right? All right, and then we will move on from there. And we're going to have a little conceptual problem for everybody. So, how would we find the zeros of the following? So here we have y is equal to x cubed minus 9x. So I want everyone to think about this equation right here. Y is equal to x cubed minus 9x. Obviously, it's not going to be the same as the simple quadratic functions that we have solved thus far. This one's going to be a little different, a little more complex. So I want you all to think about A, how is this different from the previous problems? And B, how would you navigate factoring and finding the zeros of this problem? All right, so compare it to the last problems and think about how you would solve this and what the zeros might be. I'm going to have an option for you all. Please type out your answers to this problem, think through it for a bit. And we'll be considering this coming into our next class tomorrow. All right. And now real quick, at the end of the video, I'm going to have a real quick poll for everybody to fill out basically how comfortable you are with the material, or uncomfortable. If you are, that's fine. We'll work it out in class. But yeah, please fill out the poll real quick, how you feel about this content so far, finding the zeros of polynomials. And if you have any questions, you'll also have an optional option to fill out any questions that you might have. All right. Thank you, everybody. I look forward to seeing you in class.